Hey 8th graders, today I'm going to walk you through these 3D notes. One important thing I want you to realize is although these are new notes, all of the math will be based upon the Pythagorean theorem, which we already know. The only difference is that today, instead of a flat triangle, for example like the one you see here, where we know how to do the Pythagorean theorem, we are going to do it 3D, which means that it is a three-dimensional box, for example, like the one you see here. Instead of what we're used to by finding one missing side, instead we're finding a diagonal. For example, from the letter B to H, that is our goal today, to find the diagonal of a 3D box. If you're looking at this box here, the blue triangle is showing you that diagonal. So if I'm going from the upper corner inside, this is the diagonal we're looking for. So a couple different examples I could show you. If Dory were to swim from this upper corner all the way down, that would be one example. Another real life example would be if I was trying to figure out if this box would fit a present and it didn't fit maybe lengthwise, I could see if it could fit diagonally. On your unit test, it will actually talk about a spider crawling from this top corner down inside to find that diagonal. So those are just a couple examples. So if we look at our notes here, I'm going to start with that upper visual. So we've got, it looks like we're trying to find from B to H. Here's why we cannot just perform the Pythagorean theorem. We don't know the hypotenuse, which is this diagonal. We don't know this leg. So far we have two things we don't know. However, this particular leg, which looks like we have 8 centimeters here, because it is a rectangle, this is also 8 centimeters, this leg here. Unfortunately, that means I only know one piece of information from this triangle, and the other two tell me that I don't know enough. So what we need to do is we need to find this missing piece. And it is the hypotenuse of the other triangle, but it will become the leg of our blue triangle. So what we actually need to do, if we look here, they have actually peeled away the bottom triangle. So we need this part, I'm going to underline it. We need this part right here, okay? So what I'm going to do, and please copy this down, is I'm going to do step 1 right over here, okay? Step 1 is using the Pythagorean theorem to find this missing side. Now some of you might be thinking, well, this is 10 centimeters. I'm missing 2 again. But we need to realize that this is a rectangle. So if this side is 4 centimeters, this side is also 4 centimeters. That's why when we peel away this bottom triangle, this is the 4 centimeters matching here. This other leg is 10 centimeters. So we are looking for C, or the hypotenuse. So if I go and write the Pythagorean theorem, I'm going to determine this side is A, this side is B, but remember that doesn't matter. You can switch your legs. So if I do A squared, that will be 10 squared, plus B squared, in this case my B is 4, and I do not know C. Now I'm going to perform the squares. 10 squared is 100, plus 4 squared is 16. Once I add those, I will get 116, which is C squared. But since I just want the length of C, I could go and find that I have to take the square root. Now I know the length of C. Now to help you see that visual, I'm going to write that right here. Okay, I'm also going to write it here because that is C, and I'm also going to write it here. The reason I'm doing that is I'm showing you that this bottom portion, I found the length even though it might look a little different, okay? So I'm going to actually look at my 3D box, and I'm going to pull out my triangles here to show you that I found that this hypotenuse, and I might write it with blue so you can see a little better, is the square root of 116. Now looking at this visual, I'm going to back up a little bit. I want you to see that that hypotenuse becomes a leg of my blue or upper triangle. So those will actually be the same. If we look at that on paper, we can see here, there is that leg, but it was a hypotenuse, okay? Now, we have enough information, but I want to tell you this square root, you can go and put it in a decimal. But because we're going to go and square it in our next Pythagorean theorem, it will actually save you more time if you do not. So let's go to step 2. Okay, step 2, we now have enough information. So what this visual is showing you is that it has peeled out that upper triangle, which in my example was the blue one. So we know that 8 because of our leg, but we know this bottom one is the squared root of 116. So this B to H is the diagonal that I am looking for. So I'm going to actually trace this in blue. You can use your own 2 colors, but I want you to see the blue triangle is different than my red one. Okay. Now, I'm going to go ahead and perform the Pythagorean theorem because I'm almost done because I'm looking for this diagonal. So again, I'm going to do A on the bottom, B there. So I'm doing squared root of 116. I'm going to square that, plus A squared plus B squared, 8 squared equals C squared. Now what I like about leaving this here, these are inverses of each other, a squared and a squared root. So those will actually cancel out. So now I'm left with just 116. So that's the plus of if you don't turn it to a decimal, those will just cancel out. Plus 64 equals C squared. When I add these 2 numbers together, I will get a total of 180, and that is C squared. Now my last step, this is that entire area of C. I need to take the square root of both, and I will just have C. So C is the squared root of 180. However, what we want to do is turn that to a decimal because it's our final answer. And when I put that into my calculator, I will get 13.42 when I round to the nearest hundredths place. And looks like all my labels are centimeters. So this is my final answer. So I'm going to kind of walk you through it one more time. The reason I had to do it twice is because I didn't have enough information for this 3-dimensional triangle. So I performed the Pythagorean theorem first on this bottom triangle.